This conference will now be recorded.
Hi friends, so today we are going to start with the Azure Databricks Master Program. So as part of this, so this is our first session on Azure Databricks. So in this particular session, we are going to see introduction to Azure Databricks. So what is introduction to Azure Databricks is we are going to understand what is big data, how this big data is generating, what are the key concepts that we need to focus to understand big data. Once we have big data, what we need to do with this data, we need to analyze this data. Why we are analyzing this data? Okay, so then what are the different services or tools available to analyze this particular data? Once we analyze this particular data, then we are going to see what are the disadvantages with the traditional services. Okay, how Databricks is coming into picture and how Databricks is going to solve the problems which we have in the traditional services. So these are the things that we are going to discuss. Let's go to here. We will learn today what is big data, how this big data is generated, big data key concepts, because if you have more than 10 years of experience, maybe your role, your profile will be considered as something team lead or architect, right? So in that case, you need to know these key concepts. Okay, what are those key concepts? Then we are going to see what is big data analytics, advantages of this big data analytics, who is using this big data analytics, what are the different domains people are using this big data analytics, we are going to see. Then we'll see before Azure Databricks, what is the early framework in big data analytics, we are going to understand. Then we will see what is Azure Databricks. Okay, today I will just introduce you with Azure Databricks, but tomorrow we will have a entire things brief about Azure Databricks. Okay, today we are going to understand, before we move to the Azure Databricks, what all the things is required, prerequisites, all those things we are going to focus on today's session. Okay, let's see what is big data. So big data is a field that treats ways to analyze, systematically extract information from different sources. What it means, you are going to extract data from some different devices or different storages. It can be data lake storage, on-premise storages, file systems, RDBMS systems like on-premise SQL Server or Azure SQL Database, Azure Synopsys Database. Okay, the like data warehouse. So different sources you are going to use to fetch the data. Once you extract the data from these sources, what you are trying to do is you are going to analyze this data in a systematic way. Systematically, you are going to analyze this data. This is the one kind of definition you can explain. Second definition for big data is, you can say, like you are dealing with the data sets that are too large or complex. Meaning, too large means it's a very big. Whatever data you are going to analyze, the data is too big, too large or complex. This kind of data you are going to deal. Next, so what are the different data we are going to implement? Okay, example, we are going to implement a live data, we are going to implement a historical data, we are going to implement analytical data, we are going to implement predictive data, data for change. What all these things, if you remember, whoever is working or whoever is not working, you will be able to understand these terms very easily. Live data meaning whatever data you are collecting from customers, you are going to process this data to understand when something is not working. Okay, example, if you understand, you are taking some transactions from some ATM, then suddenly you found that there is no transactions coming from particular ATM, then you can think that this ATM is not working. So how you will come to know this ATM is not working? You are going to process live data immediately. Some transaction happens immediately, that event comes to you. Okay, if some events you are not receiving for last 30 minutes, you can suspect and you can confirm that this particular ATM is not working. Okay, that is the live data processing. If you process live data, you can able to understand what is not working currently. Next, if you go to historical data, in historical data, you are going to save all the history of data to understand what was not working and what was working. Okay, when that was working, when that was not working. Okay, all this history you are going to understand. Okay, now example, we have COVID-19. Now people is looking back and they're checking, okay, every 100 years we have some pandemic. So how they are able to tell every 100 years we have a pandemic? They are analyzing historical data, all the data they have saved, and with the help of all the data, all the data points, they understood that. So like every 100 years we have this particular pandemic. Okay, so that's what we are going to analyze with the historical data. Next, let's go with analytical data. So analytical data means on same data you are going to understand why this is happening, okay, why this is not working. So you're going to understand the root cause analysis we are going to do. That is called a analytical data. Next, predictive data. So now you understood why, like you understood that it is not working currently. When it was not work, like in history, do we have any time when it is not working? Okay, we got some data points. Then we are also understood root cause analysis. Maybe in the past some issue came and you have fixed it. You also have to do analytical data. So what is meant by extracting is when something is not working, you need to find the root cause analysis. Why that is not working at that particular time? That is analytical data. Now, very important for your business is, okay, you are clear. It is not working currently. It was not working in the past also. We found the root cause analysis. But do we have any situation in the future it is not going to work? We need to predict our future also. When we predict our future, we can take care, we can like mitigate these particular issues, we can mitigate the business impact, we can minimize the business impact if we understand when this is not going to work in the future. So that is nothing but a predictive data. So this predictive analysis, everything where we are going to by using machine learning. Why machine learning is getting more popular nowadays? Because it is going to give you future. Everybody want to see their future, maybe next to 10 years, how my job is going to be if I learn cloud. So if I start my business, how my business is going to be next 10 years. So everybody want to see their future. So for that we need to do a predictive data implementation. We need to do, who is going to do? Data scientist will do. Okay, data scientists are going to do this predictive data analysis to identify when this is not going to work in the future, or what is the future of this particular business. Okay, data for change. So data for change is basically you need, with the help of data, you are going to understand what customers are looking for. Example, you have introduced one mobile. In that mobile, people are looking for some new features which is available in some other mobile. Then what you need to do, you need to take all these like all these comments, you need to introduce a, like you need to put all these particular features in new mobile. You need to introduce this new mobile to the customers. So that's how you need to change this data. Whatever data you have, maybe you have manufactured one mobile, you have some data. This data you need to change now, because you need to add some extra features to satisfy the customer. Okay, we want to change how something works. Okay, so that entire business process we need to change. Understood? Okay, now anybody have any doubts in this particular slide? Manohar, clear?
Sir, can you please explain more on data for change?
Yeah, data for change is example, let's say you consider a Flipkart. Okay, you placed some order, now you are going to change, like you are going to cancel that particular order. So when you are canceling, they are going to ask you, right? So why you are trying to cancel this particular order? So there are different reasons for canceling your order, right? The first case is maybe delivery time. Maybe they are taking more time to deliver the item. Maybe the product cost is too much, okay, if you compare with other websites. Or maybe you directly, if you purchase from shops, so you compared this price, you understood that the price of this particular item in this website is too high. So that is the another call. So likewise, you are going to mention all these points. Now they are going to understand, okay, so if we are mentioning high price here, then next time they are going to taken care, right? So they are going to taken care. Okay, high price, whatever items we have, those items we will not sell, because you need to put exact price whatever other people are offering. Okay, that is one case. Second case is here in same thing. Second case is example the delivery. Okay, it is taking more time. Now you need to change this particular how you are delivering or how you are doing business. You have to change. Maybe whatever item you are delivering in 10 days, now you need to change some data to make sure, like change data means you are going to change the process to deliver this particular item in like 5 days or 3 days. So meaning basically whatever data you have defined, whatever flow you have defined, that flow you need to change. Why you are changing this? To achieve a better business. Okay, clear now? That is the change in your business process. You are changing.
Got it.
That is data points you are changing. Okay, any other questions? Netra, Shashi, Lakshman? Okay. Okay, thank you if you don't have any question. So now we understood what is big data. It's basically analyzing the big data sets in a systematic way. Analyzing big data sets or complex data sets in a systematic way. So we can analyze live data, we can analyze historical data, we can analyze all this data to understand why this is not working. Root cause analysis. We want to understand prediction data, like predictive data. We want to like we need to produce or we need to generate. How you can generate this predictive data? So example, it was raining last 10 days day by day. So you can, like if you submit this data set to machine learning is also going to tell you next to 10 days also it is going to rain day by day. Okay, so mission, whatever you teach to mission is going to do like whatever learning it has done. So with this learning it will try to answer your questions. So now what happens? Last historical data you are going to ingest into your machine learning. Mission will learn these things and it will try to predict your future. When it is predicting your future, new data you are generating here. Okay, future data you are going to generate from the historical data. Okay, now we understood what is big data, but what are the different ways how we are getting this particular big data, how we are generating this big data? We will see now how big data is generated. So this is big data. First thing is transactions data. Example, if you transfer some amount to another person or you are purchasing any item, okay, anything, all these are the transactions. So when you make any transaction, all this data we are going to collect it and we will store it for analysis. Next, we have a scientific data. Example, it can be a defense like a defense research, it can be healthcare research, anything, scientific data. Now everybody is like researching on COVID-19 vaccine, right? So that is also a lot of data. Every country is trying to collect the data as much as they as much they can collect from other countries. Like as we know now, Russia has shared some information with India to to manufacture the COVID-19 vaccine, right? So in the same way, like the countries or whatever, this research data we are getting for processing. Next, we have a sensor data. Okay, sensor data is basically from underground we will extract petrol and all these things. For these, people will go and they will try to extract it. So in all these cases, what happens is you are going to extract the temperature and all weather condition like every minute or every second. So all this extracted sensor data you are going to store it and you are going to analyze this data. Okay, so how this weather changes is happening. Okay, next, social media. If you post any tweet or you are posting any video, audio in Facebook, all these are the data you are collecting again. Next, we have enterprise data. Enterprise data means with if you consider any big companies, what big companies will do, enterprise companies, they will manufacture things and then they will supply this particular manufactured products to the wholesale. From wholesale, these will come to the market. From market, they will distribute to the small shops. From small shops, these items will be distributed to the end user. So this entire flow they are going to define, and the defining that entire chaining of the process. What happens is you are going to collect all the data. Okay, shipping of the items, what is the status of shipping, what is the manufacturing status, okay, what is the sales status. So all this information, because when you have more demand, you need to increase the manufacturing as well. So for this, we are going to have a lot of data. Next, public data, whatever data you are seeing, okay, whatever data is, you can able to read it from Google or from outside, all this data is a public data. Okay, so maybe somebody is interested to write his own story, so they will write some own story and they will post it in different websites, right? So many people, they may write their motivational stories, all those things. So all the data is also we can analyze. Okay, maybe how many people are changing by reading this particular article, how many people are changing by reading this particular article. So that is completely public data. Anybody can able to write, anybody can able to read. Okay, so these are the few areas from which we are getting the data, but not only this, we have many more ways we are getting the data. Okay, any questions here in this slide? Anybody have any questions? Okay, Lakshman is clear. Okay, I hope everybody is clear on this. Now let's go to how big, what like a big data key concepts. As I said, if you have more than 10 years of experience, you need to build the solution. Okay, maybe as a solution architect. Okay, so you need to build the entire solution. So for that, you need to understand 3 different key concepts with respect to big data. One is volume of data. What is volume? The size of data. Okay, next, you need to understand data velocity, how quickly data you are going to receive. Okay, maybe you see, you know how much data. Okay, this can be a 1 GB of data, this can be a 100 GB of data, but now you need to understand this 1 GB of data or 100 GB of data, in how much time you are going to get, whether this 100 GB of data you are going to get it in 1 hour, you are going to get it in 1 day, you are going to get it in 1 month. So that time you need to mention here, data velocity, how quickly you are going to get this much data. Finally, you need to understand third parameter called data variety. So what are the different types of data, whether it is a structured data, semi-structured data, unstructured data. Okay, let's go one by one. Data volume. So volume provides amount of data and form of data. Amount of data means it can be a like terabytes, it can be number of records, millions or billions of records, like millions, billions of transactions. It can be a number of tables or number of files. Okay, in this way you are going to define the data volume. So this is the first and most important thing. Before you build the solution, you need to get the requirement from the client. Okay, you need to ask client, so can you tell us what is the data size? Okay, so what is the data velocity? So how quickly your data is going to refresh, or how quickly your tables are going to update? Okay, how you want us to load the data? Do you want us to load data every hour or every day or every week, every month? Okay, so all these questions you need to put in front of the customer. Now, what is data velocity? So velocity provides the time at which data is collected and analyzed. Okay, clear on this? So velocity provides the time at which data is collected and analyzed. So example, you can see it can be a near-time data, real-time data, streaming data, batches. Batches means what it is you are going to collect data, maybe 1 hour data or 1 day data. It can be 1 week data. You are going to collect it and then you are going to send for the processing. Okay, here real time or near real time. Near real time means maybe here near real time means 1 minute data you are going to collect and you are going to process it. Okay, maybe you are going to store 2 minutes of data you are going to collect and you are going to process it. Real time means once data comes, immediately you are going to process it. Okay, streams means events. Example, what happens when you are like if you are presenting any webinar, multiple people are going in, they will come into online and they will comment, right? So all these comments will go as an event, one by one, streaming. Okay, like pipeline, one by one event will keep on coming. So those are the streams. So you need to understand, so whether your data is a batch, if it is a batch, we want to process it daily or hourly or weekly, monthly, all these things you need to know. Finally, data variety. Variety provides the type of data collected. What is the type of data collected? So it can be structured, it can be semi-structured, it can be unstructured or mixed type. Okay, kind of structured, unstructured. We are not sure. Sometimes maybe structured, sometimes we are getting unstructured. Okay, so you need to understand what type of data you are going to get for processing, because if you know what type of data is going to come, you can able to handle much more efficient way. Okay, anybody have any questions in this particular slide? This is very, very important slide, key concepts.
What I'm not able to understand.
What you are not able to understand?
This near time under data velocity. What is the near time?
Near time means it's not immediately you're not processing. It's kind of a batch, but batch is like maybe batch. You can say near real time. You can also say it as a batch. But what is the difference between near real time and batch? Is batch means you can say like more than 1 hour data you are going to collect and process. Near time means maybe 1 minute data you will collect and process. Okay, 2 minutes data you will collect and process, something like that. Very less time data you will collect and process. That is a near time. Batch means maybe it can be 1 hour or 1 day, okay, 1 week, 1 month, something like that. Is Devendra clear on this?
Yes, Malaya. Thank you.
Okay, any other questions, friends? Abhishek, you have any questions? Manohar? Okay. Thank you. Let's go to next slide. So big data analytics and advantages, the advantages of this. See, now as of now we understood what is big data. Okay, systematically analyzing the complex or too large data sets. It's nothing but a big data. We understood that, and how this big data is like generating. Then we understood the different key concepts that we need to understand about big data. We learned. Now, what is big data analytics? Okay, so now we know the term big data. Now one more term is adding, that is analytics. What it means is, whatever data you have collected, the data you need to analyze. Why you need to analyze? We have seen, to understand why something is not working now, to understand why something was not working previously, to find out the root cause, or to find the future, in future when this is not going to work. So to identify all these, to answer all these questions, you need to analyze your data. Not only this, example, you are like retail domain, and you are selling lot of products. Okay, now what happens? Suddenly sales coming down. So how you will know? You need to process live data, or at least you need to process 1 day data, like batch. As a batch, 1 day data if you process, you can compare with yesterday sales and orders. If you compare with today's sales and orders, you can see the difference. When you see the difference, if the sales is going down, so you can understand that something is going wrong. So immediately you can make the correction. The here hidden pattern is sales are coming down, that you are not able to identify if you simply look at outside, right? You need to analyze all the data which you have. So once you analyze the data, you are going to identify your hidden patterns. What are the hidden patterns? Sales are coming down. Next, so what are the corrections we are going to take now? So you need to take a smarter decisions to handle this particular situation. Okay, so to do all these things, we need to analyze the data which we are collecting. See, big data analytics examines large amounts of data to uncover hidden patterns, meaning to discover hidden patterns, whatever things are happening in your business, to identify, to uncover, to discover this particular hidden patterns, we are going to analyze or examine these large data sets. Once we have done that, so we are going to take the necessary steps, meaning we are going to do the corrections. We are going to do the corrections and the other insights, meaning we are going to take the other decisions to streamline this particular process. Maybe sales are going down. You need to do something about that. Okay, you need to analyze why sales are going down. What is the problem? So which factors are impacting on the sales? So you need to analyze these things and you need to take in care. Okay, next, come to next one. So what happens is, before this point, you need to understand with the traditional technologies, if you try to analyze these large data sets, it is going to take too much time and the process is very, very slow. So example, you want to understand how was yesterday business, maybe how was yesterday sales. So if you try to process this particular data by using traditional services and the tools, it will take more time. Maybe it will take 2 days or 3 days to get your to get the answers from the yesterday data. But with today technology, with today tools and services, you can process large data sets immediately and you can get the answers immediately. Meaning whatever hidden patterns we have in your data, example, your sales are going down, or it can be in healthcare domain. If you look at COVID-19, so you're going to identify the number of people who are impacting with this virus every day, whether the number is increasing or decreasing. How you will know? You need to collect all the data, then you need to put, you need to find some kind of a information. What you want to find from this particular data is, example, let's consider from the patient I have taken few details. What all details I have taken? When patient came to hospital, I'm going to take the his name, his age, and from which place he belongs to, what are the symptoms. So when I have all these things, I can answer a lot of business questions. The first thing is, in that particular area, whatever area he came from, in that area, how many people impacted? Okay, so how he got impacted? Okay, what is the reason how he got impacted? Next, what are the symptoms are showing to him? And you can compare. Okay, so when you analyze 100 people, you will come to know what is the common symptom. Okay, when you analyze 100 people, most of the people from which area? When you know most of the people from which area, you can also understand why more people are impacting in that area, whether the weather conditions are impacting. So all these things we can able to identify. These all are the hidden patterns within the data you have. So to find out all these things, if we use traditional services, meaning old services, okay, what happens is it will take more time to give you answers, all these answers, whatever answers you want to understand, right? Why this area people are impacting, whether the problem is with the weather condition, the problem with the persons here, they are not using mask or something. So you are going to identify the root cause here. Okay, so to identify root cause and to do all this analysis, what happens is, if you use traditional technologies, it will take more time. That's why we need to use the today services and tools which are available. So if you use today technology, with today technology, it's possible to analyze your data and get answers from it almost immediately. Okay, with today technology, you can get the answers almost immediately, but an effort that slower and less efficient with more traditional business intelligence solutions. Okay, slower and less efficient if you use more traditional business intelligence solutions. Okay, next. So with today's technology, the cost also you can immediately get answers. And one more thing is, with the less cost is also going to reduce. How cost is going to reduce? Because we are nowadays, everybody know, we are using the cloud. In cloud, even if you want to store large amount of data, we can able to store it store it with very cheap storages. There are storages where you can store some petabytes of data with very minimal cost. Okay, so that's how you're going to reduce the cost. Big data technologies such as Hadoop and cloud-based analytics bring significant cost advantages when it comes to storing large amount of data, because as you know, if you look at AWS S3, okay, in AWS S3 what happens is you will have different classes in it. Infrequent access, glacier. What happens there, once you think some data you are not going to use for a long time, then that entire data you can archive it and store it in a glacier. So whatever data you have stored in glacier, it is very cheap, very cheap. Okay, but whatever data you are going to use frequently, that data you can put it in a infrequent class in AWS S3. Okay, so when you have differentiated, when you are storing different data in different classes, that's how you can optimize the cost. And even you are storing large amount of data, you can pay very less amount. Even if you use data lake storage, Gen 1, Gen 2 or blob storage, anything, what happens is you can store data with a very minimal cost. Okay, so you can see, plus they can identify more efficient ways of doing business. Example, as I said, so you are going to identify which data I'm going to use frequently for my business, which data I'm not going to use frequently. So whatever data you are not going to use, that data you can archive it and put it in a different classes for reducing the cost further. Okay, next. So with today technology, as I said, you can do like processing faster and you can take the better decision making. Okay, you can achieve these two, faster and better decision making. You can able to achieve it if you use the today technologies. See, with the speed of Hadoop and in-memory analytics. In-memory means Spark. Spark is a in-memory analytics. If you use a in-memory concept, processing time is going to be reduced like anything. Now, okay, combined with the ability to analyze new sources of data. Now what happens is, previously, suppose example, if you consider even MapReduce, when Hadoop comes, we have a engine is a processing engine is MapReduce. In MapReduce, what happens is, even your data is available in SQL Server, SQL Database, data like Gen 1, data like Gen 2, doesn't matter. First you need to bring data into HDFS. Once you bring data into HDFS, from there you need to read this data. Okay, then you need to process it. But with today technology like in-memory analytics such as Spark, we can directly connect to the any source and we can able to analyze that particular data. Okay, meaning combined with the ability to analyze new sources of data, meaning you can connect to any source. It can be directly, example, from Azure Databricks, we can connect to the AWS S3 data like Gen 1, Gen 2, AWS Redshift. So you can connect to AWS or Azure, you can connect to any source. Okay, businesses are able to analyze information immediately and make decisions based on what they have learned. Okay, so based on whatever they have learned from the data, they are going to take the better decisions. Okay, next, new products and services they can introduce to to identify customers needs. They are going to identify customer needs. Based on customer needs, to satisfy the customer, to satisfy the customer, they are going to introduce the new products and services. Okay, example, if you look at all the website nowadays, they have some live chat, right? So you can, if you look at any website, directly we can chat with some robot, right? So that particular robot, we can able to chat. If it is not able to answer, it will redirect our request to the agent, whoever is the person who can help us. It will redirect our request to that particular person. So this is the one of the new product or service that is introduced in almost all the website nowadays. Why they have introduced these things? Because that is the customer need. Customer wants to get the wants to get the answers for their questions immediately. So that's how they have identified the customer needs. To satisfy customer, they have introduced the new products and services. Okay, so with all these things we need to understand in big data analytics. Okay, we can reduce the cost. If you want to do big data analytics, you can reduce the cost and you can see faster, better decision making we can achieve. And as per customer needs, you need to introduce the new products and sales. Okay, what is big data analytics? Whatever data you have collected, that data you are going to analyze. Why you need to analyze this data? To identify hidden patterns. Why you need to identify hidden patterns? To streamline your business. Okay, to correct your business. Whatever business is impacted, you need to rectify. You need to take some decisions to rectify those mistakes. Okay, so to do all that, we need to understand, we need to analyze our big data. That is nothing but a big data analytics. With today technology, we can able to do this big data analytics with less cost and faster, better decision making we can able to do. And finally, we can able to introduce the new products and services to the customer as per their need. So with this, what organizations are going to achieve? With these big data analytics, organizations, they can take the smarter business decisions. Next, more efficient operations, how they are delivering operations. They can deliver much more efficient way. Then they can achieve the higher profits. Finally, they can make customer happy. Okay, when you make customer happy, so they will try to purchase new products from same website. Example, you will book some bus. You are going to travel in that particular day or in that particular week. What happens if you satisfy with that particular travel, then next time also you are going to book same bus. If you are not satisfied, you are going to book another bus, right? So that's how. So you need to make customer happy first. When you make customer happy, ultimately you will get the high profits. Okay, any doubts in this particular slide? See, mainly in this slide, we have a lot of theory. Let me just give you 1 minute overall idea. See, big data analytics is nothing but examining the big data sets to identify hidden patterns. With today technology, we can able to identify these hidden patterns much more quickly with less cost. So as we are going to understand this analytics quickly, we can able to take the better decisions very fast. Okay, quickly we can take the better decisions, and we can also introduce the new products and services as we understood what is customer needs. Okay, that's what you need to understand from this particular slide. But anybody have any questions in this slide? Any questions here? We have a lot of theory part in this particular slide. Yeah, that part will cover, Shashi. What is structured, semi-structured, and unstructured data? Okay, all the data. Example, see one example. You can look at your tables. All the data which you are storing in a table, you are going to define the fixed number of columns in a table, and at any point in time, you will store same number of columns of data, right? So that is the structured data. Whatever data you are storing in table, that is the structured data. Semi-structured means you can understand XML files, JSON files. All those are the example for your semi-structured data. Unstructured data means all are audio files, video files are the your unstructured data example. So with this you try to understand, but we will explain more about structured, semi-structured, and unstructured data in the upcoming sessions. Okay, any other questions? Manohar sir, clear? Debashish, Devender. Can you confirm our chat window, or you can unmute yourself and speak out? Everybody's clear? Abhishek sir, clear? Manohar?
Yes, clear.
Yeah. Thank you. Thank you. Let's go to next slide. So here, let's see who is using big data analytics. Big data analytics used by life science. Life science means all biology researchers, all the people whoever is doing research on health, humans health. Okay, basically health related research data. Okay, next banking domain. people are using, and healthcare domain, and it's retail domain. You know, right? Banking domain means all the banking services. Okay, depositing, crediting money, all those things. Healthcare means all patient like patient's information. Okay, with the patient's information, you are going to understand. Okay, if so, how COVID-19 is they are able to identify because they understood something. The person who impacted first time, that person has a different symptoms which is not seen in the past. So that's how doctors suspected that this is something new, and they sent this particular virus to the research. So here they found that particular thing is something virus. Okay, so this is basically you are going to just collect some information and analyze few things here. But if you want to go in-depth analysis, you need to send that particular samples to the researchers or scientists. Next, retail means sales. It can be any product. Okay, product sales, all these things. Government. So government organization. So for all the public, they are going to give you some Aadhaar card, all these things in India, right? So what are these? So all this is the data. So with this data, you are going to analyze what you are going to analyze. Okay, every time you are going to analyze like how many people, like what is the percentage of youth in India, you need to understand. Okay, from this data. Okay, if you analyze this government data, you are going to understand that. Next, the literacy rate, you are going to understand. So all these things we are going to understand from the analysis. Next, we have a manufacturing. So in manufacturing also, people are using this big data. And okay, example, when you manufacture 100 products, so what is the percentage of products which are breaking? These many products analyze. Okay, why these products are breaking? So you are going to analyze those things to manufacture better product in the. Okay, clear on this? Any doubts in this? Okay, how banking people are going to like use this big data analytics? Okay, they are going to use this particular analytics to identify which customer we can provide like credit card for, to which customer we can provide a personal loan. So they need to analyze, because based on our account details, how much money is crediting every month, how much money we are spending. So based on that, once they analyze, they are going to identify which customers are the good customers whom they can provide a credit card, whom they can provide a personal loan, all those things. Next, if you come to retail, in retail also, people are going to analyze this particular product. If it is going like more sales are happening for one product, they're going to understand why more sales on this particular product. Okay, what example, if you look at nowadays, everybody's purchasing smartphones and laptops. So there are a lot of sales on laptops and smartphones. Why? Because now due to this pandemic, many people are attending classes in online. Okay, so for your kids, all the people, they have to purchase smartphones. Some people, instead of purchasing smartphone, they are directly purchasing laptop. So that's how product sales are going up due to some other factors. Okay, so all this analysis they are going to do. Okay, in different domains, this big data analytics we are going to apply, friends. Okay, clear on this? Okay, let me go to next. So early framework in big data. So before Azure Databricks, we have an early framework. Here, what happens is, an early framework for analytics, it let platform to solve each aspect in isolation. What is each aspect? There are different aspects. Example, we have a data engineers who will take the data from customers. Okay, then once we collect this data, we are going to analyze this particular data. Okay, first, once we collect data, we are going to analyze, as a data engineer, he will engineer on the data, meaning he is going to calculate some extra fields. Example, the total value, like total transactions that has happened in a month, total transactions happened per day, per month, all these things we are going to analyze. Next thing, second aspect is, once we have these data sets, next aspect is we need to identify the future with this aspect. Okay, who is going to do this? Data scientist. By using machine learning, we are going to data scientists are going to do the future analysis. Next, we will have a data analyst who is going to understand the current business. Data engineer who will prepare the data set, first aspect. Machine learning, that is data scientist who will identify the future. Data analyst or business user who is going to identify current business. Three aspects you need to be clear. First aspect is data engineer who will prepare the data set. Data scientist who is going to identify the future about your business. Data analyst who is going to identify the current business. Okay, three aspects. What happens is before Azure Databricks as an early framework, all these aspects, okay, organizations ended up with separate teams to independently handle. For data and for data engineering, like big data analytics, we have data engineers. They used to work isolation, like they used to work separately. Machine learning team, data science team, they used to work separately. Then real-time analytics, we have a business users who are going to work separately. Okay, there are these three different people who are going to work separately. Next, so do we have any solution for this? All these people are going to work separately. Now there is, if they want to, example, this data scientist guy want to get some data from data engineering person, because once we provide data sets to machine learning team, then only they can able to predict the future. Okay, without data they cannot do anything. So that's why these people dependent on this big data analytics, like data engineering people. So but the problem is all these people are working in a isolation separately. Okay, there is no like interaction between these three people. Now everybody is working as a independently. We have three different independent teams. Now do we have any solution to handle this situation? Yes, now we have a Azure Databricks new analytics service called Azure Databricks. It's a fast, easy, scalable, and collaborative Apache Spark based analytics service on Azure. Basically, it is very fast because in Databricks we are going to use a Spark. Spark is in memory. If you think any service is in memory, it will be a much more faster. Now it is easy and scalable. Easy means you don't need to install some tools, external tools to write the code. Automatically you can write code by using a notebooks. Directly you can create notebooks simply, okay, with the very easy steps you can able to write the code. Scalable, you want more number of nodes. Okay, you don't know what is how many servers you need for processing your big data. You don't need to worry, you will have a auto scaling option. If you configure, I want to take 2 nodes to up to 10 nodes or 1000 nodes, depends on how much data you are trying to process, it will take optimized number of nodes automatically. You don't need to worry. Next, collaborative means all the people can work as a team, as a group, as a one team. Collaborative means all the people they can work as a collaborative, as a single team. They no need to work in a isolation. Okay, so that's what Azure Databricks is fast, easy, scalable, and collaborative Apache Spark based analytics service on Azure. Next, seamlessly integrated with other Azure services in an interactive workspace. So as I said previously, from MapReduce, if you want to access any data which is there in database or storages, first we need to bring it to the HDFS, Hadoop Distributed File System. So you will not be able to connect to the services directly. But with this particular Azure Databricks, what you can do is you can directly connect to the different Azure services. Example, you can connect to data like Gen 1, Gen 2, blob storage, SQL database, like Cosmos DB, anything you can able to connect directly. Not only Azure services, you can also read data from AWS S3, AWS Redshift. All those things we are going to see. Okay, now it reduces cost and complexity with a managed platform that auto scales up and down. As I mentioned, so as per the need, it is going to take the more number of servers. As per the need, it is going to reduce the number of servers. Suppose, example, if you consider when you want to build 2-floor house, you need more people. Okay, but I want to construct only one room in a house. Just you can end it, like you can able to finish it with very few people. So depends on how much work you have, you need to decide the number of people. In the same way here, depends on how much data you have for processing, you need to take the number of servers. But you don't know how much data you are going to submit each time. each time the submission of the data size is going to change. So how you are going to decide the number of people? You don't need to worry. You can simply configure. I want two servers to 1,000 servers. Then depends on the data, it will keep on increasing. If you submit more data, it will keep on increasing up to 1,000. If you submit a less data, it is going to reduce thousands to the again 2. Okay, based on how much data you are going to process, it will scales up and scales down. What it means, it will increase the servers and it will decrease the servers. Next, in this Azure data, as I said, data scientists, data engineers, business team like analytics team, all these people, they are going to work as a single team. See, data scientists, data engineers, business users, okay, data analysis team. So all these people are going to work as a single team. There is no isolation. Everybody, they can work in a same platform within the Azure Databricks. Now, it is making process of data analytics much more productive and secure and scalable. Okay, it's more productive because all the people are going to work as a single team. You don't need to wait for some data sets and all those things. Everything is ready in a same platform. You can able to process the data quickly and achieve the more productivity. Now you don't need to worry about security. Directly Azure Databricks connected with Azure Active Directory to control your security things. Next, as I just discussed, you can automatically scale up and scale down, depends on your need, the number of servers. Next, as I said, it is compatible with the tools and services which we know and trust. Example, it can connect to the Azure Active Directory, it can connect to the Power BI, also integrate with the Microsoft Azure Storage. Not only Azure Storage, it can connect, as I said, Amazon S3 like AWS S3, AWS Redshift, data like Gen 1, Gen 2, Cosmos DB, or like SQL database. It can connect to all the services almost. And it can also connect to the Azure Synapse Analytics. That is nothing but a Azure data warehouse. Okay. So this is what we have focused on today. And tomorrow we will learn what is Azure Databricks completely. Okay. So what all things that we can within the Azure Databricks workspace, that we will see tomorrow. But today we have learned this. So everybody got some idea what is big data, how big data is generated, big data key concepts, what is big data analytics, advantages of big data analytics, who is using big data analytics, different domains we have discussed, right? Life science, healthcare, retail, banking, government, okay, all these manufacturing, different domains. People are using big data analytics. Early framework, as we discussed, all the people are working in a isolation. Now Azure Databricks is allowing all the people to work as a single team, as a collaboratively, all the people can work within the Azure Databricks. Okay, any questions in today's session?
Malay garu.
Anybody have?
Hello.
Yeah.
Can we get this PPT
Yeah, tell
or
me,
some
tell me.
material like? Can we get PPT or some material can refer after some time?
See, I am asking, do you have any question? That you can request in later. Okay.
Okay.
Anybody have any questions? Okay. So I will share this PPT. Don't worry about the documentation and all those things. Try to get the answers if you have any question and try to learn the things, friends. Okay. Okay then. Thank you all. Thank you if you don't have any question.